Let me introduce you to Don Andres, a 72-year-old man whose down not only marks the beginning of the day, but also signifies his unwavering sacrifice to ensure his family's well being. Don Andres is part of the 12 million Mexicans who suffer from diabetes. Diabetes is one of the biggest challenges that we Mexicans face today. This chronic disease has become the second leading cause of death in our country. Don Andres' life is about to become even more complicated. He's unaware that he has diabetic nephropathy, and it can progress significantly before it can be detected. Don Andres is facing an uncertain future, where early detection could be crucial for his well-being and that of those who depend on him.
Patients with diabetes may face various complications, such as a diabetic nephropathy, which is a renal disease with macroangiopathic complications. This means that it can cause the walls of the small arteries in the heart to not function properly, affecting the flow of the oxygen-rich blood to the heart.
In Mexico, 1 in every 3 patients with diabetes suffers from diabetic nephropathy. Only in 2021, they were diagnosed more than 6.2 million new patients.
Kidneys are a very important organ for the well function of our organism. Its main job consists on working as a filter for taking waste and extra water out of the blood and making them into urine. They help to control blood pressure and making some hormones that are important for our well being. When kidneys suffer from some kind of pathology, as diabetic nephropathy, they get damaged and are unable to filter the blood correctly, which conduct to major health issues.
The stages of nephropathy are divided into 5. The more the disease advances, the lower the renal function of the patient.
On the first stages of diabetic nephropathy, patients can have a renal function between 100% and 60%, but as the diabetes nephropathy advances, they can have less renal function, as in the last stage, where they can lose it at all.
Nowadays, there are various tests that can help us detect the diabetic nephropathy.
The most well-known are tests for detecting albumin in urine and creatinine in blood, which look for signs of kidney disease in people at high risk of developing it, but who don't now show symptoms.
Finally, there are tests focused on measuring the damage to kidney tissue. However, the main disadvantage of these current tests is that they only detect kidney damage in very advanced stages.
Diagnostic tests related to albumin as a biomarker detect concentrations of albumin greater than 30 milligrams per 24 hours. In terms of stages of nephropathy, this represents detection in the third or fourth stage of the disease, indicating a renal function between 59% and 50%.
We also have to consider that the lack of early diagnostic tests for diseases like diabetic nephropathy trust against the public health because it results in more complex patient prognosis, which not only increase the pain and suffering of patients, but also increase the cost of medical health care.
That's why patients like Don Andres won't be able to detect diabetic nephropathy until it represents a significant damage to their kidneys, in addition to being exposed to a very invasive test.
The late detection of diabetic nephropathy also represents an economic problem to the patients, related with the bills of the expensive medicines and hospital services they need to access in order to be able to dignify their lives.
Hello, we are Tec-CEM from Tec de Monterrey Campus, Estado de México.
This is our project NephroProt, a diagnosis test for the detection of diabetic nephropathy that enables the early identification of biomarkers related to this complication.
Our objectives with NephroProt were to develop a proposal for an early diagnosis system for diabetic nephropathy complementary to the current test, in order to contribute to the detection of diabetic nephropathy in its early stages. This allowing the patients to get a preventative and appropriate treatment to improve their quality of life based on healthcare recommendations from professionals.
Our diagnostic test proposal is based on urinary biomarkers. This is because urine tests are minimally invasive for patients and allow for more comprehensive analysis.
For the development of our proposal, we decided to use a system based on the use of biomarkers. which are substances that help to indicate the presence of a specific biological material for diagnostic purposes. We decided to use urinary biomarkers because they are easily extracted, which allow a more extensive analysis of the sample, and also allow us to detect different things like tubular lesions, which occur in very early stages of diabetes mellitus.
For the selection of our biomarker, we conducted a research project involving about 16 sources, from which we identified 8 different biomarkers. Subsequently, based on factors such as their presence in early stages of diabetic nephropathy, production feasibility, and detectability in urine, we chose 4 biomarkers: albumin, NGAL, transferrin, and FABP1.
One of the most important criteria we use for choosing our biomarkers was the feedback we received from Dra. Emma Picasso and Dra. Jacqueline Ansures, an endocrinologist and nephrologist who helped us to guide our project and gave us feedback for helping us to take important decisions about the project.
Albumin is a naturally occurring protein in the blood with functions such as nutrient transport, although it is not normally found in high concentrations in urine.
Even though we decided to discard the use of albumin for our proposal, since it is a biomarker that is found in more advanced stages of diabetic nephropathy.
NGAL is a protein of the innate immune system produced by neutrophils and prevents the use of iron by bacteria. It is found commonly in low concentrations in the liver, prostate, and in the epithelia of the respiratory tract.
On the other hand, transferrin is a glycoprotein with functions related to the transport and metabolism of blood iron. Normally, it is found only in the blood. Its presence serves as an indicator of renal condition.
Finally, FABP1 is a protein with the function of binding, transporting fatty acids and hydrophobic molecules produced in the liver. These 4 biomarkers are present in the urine of patients with nephropathy and are the ones we aim to detect.
In order to select our biomarkers, we took in consideration its presence in urine, its presence in early stages of diabetic nephropathy, their relationship with other diseases, and the reporting binding molecules.
For the bioreceptor, the use of peptides was proposed due to their document stability and integrity as bioreceptors, remaining unchanged even under the conditions of urine samples. These conditions include the use of pure samples or, in some cases, after centrifugation.
In order to analyze the interaction between the bioreceptor peptides and each of the biomarkers and validate their capture by the proposed bioreceptor system, a molecular docking was performed with NGAL, FABP1, and transferrin to predict conformations when a ligand and a receptor interact through mathematical computational algorithms.
The molecular docking yielded the following results for each of the biomarkers, with which we were able to predict the confidence score of binding to their bioreceptors to form a stable complex. Thanks to the molecular docking, we were able to detect that NGAL and transferrin have a higher score with very high binding possibilities, while the use of FIBP1 was discarded due to its low binding potential.
Once the most suitable biomarkers and their receptors were determined, we began researching possible detection systems, among which we found the two-component system. The two-component systems are advantageous for detecting specific biomarkers due to their simplicity, efficiency, and ability to quickly adapt to different environmental conditions.
As we established before, our biosensor will be looking for two biomarkers in the urine sample. These are NGAL and transferrin. This system, used by some bacteria, basically consists of a sensor kinase attached to a membrane and a response regulator binding unit. In response to specific stimuli, the sensor kinase phosphorylates at a conserved histidine residue, and then the phosphate group is transferred to the conserved aspartate in the response regulator. Phosphorylation of the response regulator triggers a conformational change leading to dimerization and high affinity binding. Our design is inspired by Brandwitzobium japonicum, a nitrogen-fixing symbiotic bacterium which is found in legumes, which, due to the need to detect external stimuli, possess the fix L fix G complex. This complex enhances the expression of genes responsible for nitrogen fixation when oxygen concentrations are low. By replacing the oxygen sensing domain in V. japonicum with a peptide with an affinity for NGAL and transferrin, a chimeric H key is created to initiate the signal transduction pathway for the early nephropathy biomarker diagnostic test. This is how our proposal design, the NephroProt test, presents an innovative concept of obtaining fixed L and fixed G proteins, which, throughout chemical transmission activated by a molecule with an affinity for our biomarkers, NGAL and transferrin, allows the expression of a visually detectable protein. The entire reaction is proposed to occur in a cell-free system. For the development of our project proposal, NephroProt, we decided to consider national and international regulations. For Mexican regulations, we choose two from COFEPRIS. The first one is NOM 064, which establishes the sanitary specifications of the reagent kits used for diagnosis, and NOM 015 for the prevention, treatment, and control of diabetes mellitus. For international regulations, we consider one from FDA, the Regulation of Laboratory Developed Test, that regulates the safety and efficiency of the diagnostic test, as well as the quality of the design and manufacturing of the diagnostic system. Also, we consider ISO for the quality management system of public and private organizations, regardless of their size or business activity. These regulations were really important because they help us to ensure the safety and quality of NephroProt throughout its production and use. The mission of our project goes beyond our prototype. We are also committed with the education of our community about diabetes and diabetic nephropathy. That's why on October 20th of 2023, we worked with the organization Con Diabetes y Se Puede in order to carry out a sensibilization day of this disease, where we present our project at Tec de Monterrey, Estado de Mexico, and also got the chance to inform our community and with the help with the organization, perform some glucose measurement tests. By recognizing the potential for refinement in our current design, we are actively engaged in the advancing of our system throughout strategic enhancements, particularly in bolstering the sensing capabilities with a dedicated emphasis on the controlled release of phosphates. Our objective extends beyond qualitative improvements, aiming to imbue our system with quantitative dimension that ensures markedly more precise and reliable results. In pursuit of this goal, we are meticulously refining the intricate elements of our design, working to elevate not only the overall efficiency, but also the accuracy of our system. Throughout these iterative steps, we anticipate achieving a heightened level of performance, reinforcing our commitment to innovation and excellence in our project. Our proposal design, NephroProt, could represent a new hope for patients with diabetic nephropathy. Implementing advanced medical technologies for early diagnosis and tailored treatments, such as in the case of patients like Don Andres, holds the promise of significantly improving their quality of life by ensuring timely interventions and personalized healthcare. NephroProt, bringing kidney health closer, one test at a time.